Long before the stars whispered their secrets, humanity gazed upward, piecing together stories from pinpricks of light in the night sky. The invention of the telescope in the early 17th century changed everything. It was as if the universe, once a distant painting, became a living, breathing tapestry of worlds waiting to be explored. Astronomers, armed with these new instruments, began to unravel the cosmos, revealing sights no unaided eye could dream of. Among the earliest discoveries were the moons of Jupiter, the phases of Venus, and the breathtaking rings of Saturn, each a testament to the power of lenses to pierce the veil of the heavens. In 1671, an Italian astronomer named Giovanni Cassini turned his telescope towards Saturn, a planet whose golden glow and intricate rings captivated the imagination. Through the eyepiece, he noticed something peculiar, a faint object that appeared on Saturn's western side but vanished when he looked to the east. This was no ordinary moon. Its brightness seemed to flicker, as if playing hide-and-seek with the observer. Cassini named it Iapetus after the Titan of Greek mythology, and thus began a centuries-long quest to understand one of the solar system's most enigmatic companions. Iapetus is no mere speck in the sky. With a diameter of roughly 1,470 kilometers, it ranks as Saturn's third-largest moon, trailing only the colossal Titan and the icy Rhea. Yet its size is not what makes it extraordinary. Iapetus is a world of stark contrasts and baffling features, a celestial puzzle that has challenged astronomers from Cassini's era to our own. Its most striking trait is its two-tone appearance. One hemisphere, the side that leads as it orbits Saturn, is as dark as coal, painted in reddish-black hues, while the trailing side gleams like fresh snow, covered in reflective ice. This dichotomy, unlike anything else in the solar system, gives Iapetus the appearance of a cosmic yin-yang symbol, a world split between shadow and light. The mystery of this two-tone nature puzzled astronomers for centuries. Early telescopes, limited by their crude optics, could only hint at the moon's strangeness. Cassini himself struggled to track Iapetus as its dark side blended into the void when facing Earth, rendering it nearly invisible. It wasn't until the 20th century, with the advent of more powerful instruments, that scientists began to piece together the clues. The breakthrough came in 2009 when NASA's Spitzer Space Telescope detected a vast, faint ring of dust encircling Saturn, now known as the Phoebe Ring. This ring, spanning millions of kilometers, originates from Saturn's distant moon Phoebe, which orbits in the opposite direction to most of the planet's satellites. Dust particles from Phoebe, ejected by micrometeorite impacts, spiral inward and collide with Iapetus's leading hemisphere, coating it in a thin layer of dark material. But the story doesn't end there. The dark coating absorbs more sunlight, heating the surface and causing ice to sublimate, turning directly from solid to gas. This leaves behind more of the dark material, intensifying the contrast. Meanwhile, the bright, icy trailing hemisphere reflects light and stays cooler, preserving its frosty sheen. This thermal feedback loop, driven by the interplay of dust and sunlight, explains why Iapetus wears two faces. Yet the source of the dust, Phoebe, adds another layer of intrigue. Unlike Saturn's other major moons, which orbit in the planet's equatorial plane, Phoebe follows a retrograde path, tilted and distant, suggesting it was captured from the outer solar system long ago. Its debris, scattered across the Phoebe ring, links two of Saturn's most unusual moons in a cosmic dance of cause and effect. Iapetus's strangeness doesn't stop at its coloration. Along its equator runs a ridge unlike anything else in the solar system, a mountainous spine stretching over 1,300 kilometers, rising as high as 20 kilometers in places. This equatorial ridge, most prominent on the dark side, gives Iapetus the appearance of a walnut, its surface bulging as if squeezed by an invisible hand. Scientists have debated its origins for decades. One theory suggests that Iapetus once spun much faster, perhaps completing a rotation in just a few hours. This rapid spin could have flattened the moon at its poles and pushed material toward the equator, forming the ridge before the moon slowed and became tidally locked, taking 79.3 days to complete one orbit and rotation around Saturn. Another possibility is that the ridge formed from the remnants of a ring of debris that once orbited Iapetus, collapsing onto its surface over time. Some even speculate that early internal heating, perhaps from radioactive elements like aluminum, reshaped the moon's crust, raising the ridge as it cooled. The ridge is not the only feature that sets Iapetus apart. Its orbit is unusually inclined, tilted by about 15.47 degrees relative to Saturn's equatorial plane, where the planet's rings and most of its moons reside. This suggests a turbulent history, perhaps involving gravitational tugs from other moons or even a capture event, where Iapetus was ensnared by Saturn's gravity from the outer reaches of the solar system. Unlike the orderly orbits of Mimas, Enceladus, Tethys, Dione, Rhea, Titan, and Hyperion, Saturn's other major moons, Iapetus follows a solitary path, a cosmic outsider in a system of synchronized dancers. The surface of Iapetus tells a story of ancient violence and slow transformation. Large craters, some over 500 kilometers wide, scar its dark hemisphere, hinting at massive impacts in the distant past. These ancient craters lie beneath a layer of smaller, fresher ones, suggesting a long history of bombardment. The bright hemisphere, by contrast, is smoother in places, covered in volatile ices that reflect sunlight. The dark material, only about 25 to 30 centimeters thick in some areas, overlays the icy crust, a testament to the slow accumulation of Phoebe's dust over billions of years. Intriguingly, the ridge itself is punctuated by craters, indicating it formed early in Iapetus's history, before the moon's surface was reshaped by later impacts. Modern technology has brought Iapetus into sharper focus. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, captured stunning images of the moon, revealing its ridge, craters, and two-tone surface in unprecedented detail. Infrared and ultraviolet observations, impossible in Cassini's 17th century era, have mapped the distribution of ice and dark material, confirming the role of the Phoebe ring. Yet even with these advances, Iapetus guards its secrets. Why does the ridge exist only along part of the equator? Could it be the remnant of a primordial event, like a collision or a lost satellite? And why does Iapetus's orbit tilt so dramatically compared to its siblings? These questions linger, challenging our understanding of how moons and planets form. Saturn itself is a marvel, a gas giant with a system of rings and moons that rivals a miniature solar system. Its rings, composed of countless icy particles, stretch across hundreds of thousands of kilometers, shimmering in the sunlight. The 8 major moons Mimas, Enceladus, Teeth, Dione, Rhea, Titan, Hyperion, and Iapetus each have their own quirks. Enceladus spews icy plumes from its subsurface ocean, hinting at potential habitability. Titan, larger than Mercury, boasts a thick atmosphere and lakes of methane. But Iapetus stands out for its sheer oddity, a world that defies easy explanation. Imagine standing on Iapetus's surface, gazing at Saturn's rings, visible from its distant orbit. The planet would loom large, its rings a delicate arc across the sky. On the dark side, you'd stand amidst reddish-black terrain, the ridge towering above like a jagged spine. On the bright side, you'd walk across fields of ice, the ground sparkling under Saturn's faint glow. This is a world of extremes, where every feature tells a story of cosmic forces at play. The study of Iapetus reflects the heart of science, a balance between what we know and what we yearn to understand. Each observation, from Cassini's telescope to the spacecraft named in his honor, builds on the last, refining our picture of the universe. Yet the unknown persists, inviting new theories and fresh perspectives. Perhaps Iapetus formed in Saturn's early disk, shaped by the same forces that sculpted its rings. Or perhaps it wandered in from the outer solar system, a captured traveler with a tale of distant origins. The ridge might be a scar from a violent past, or it could be the frozen echo of a moon that once spun too fast for its own good. As we approach 350 years since Iapetus's discovery, its mysteries endure. Telescopes now capable of peering into wavelengths invisible to the human eye, and spacecraft that journey to distant worlds, have transformed our view of the cosmos. Yet Iapetus remains a reminder that the universe is vast and complex, its secrets revealed only through patience and curiosity. Like the astronomers who first turned their lenses skyward, we stand at the edge of the unknown, ready to uncover the next chapter in the story of the stars.